Hello, welcome to Math with Noise. We are solving a question from topic of differentiation. The diagram shows a solid object in the form of a cylinder of height h centimeters and radius r centimeters. On the top of the hemisphere of radius r centimeters, given that the volume of the object is 280 by centimeter cube, part 1 is express h in terms of r. So first let's write the equation of volume. So volume equals to, so volume of this hemisphere plus volume of cylinder. So volume of hemisphere would be just half of volume of sphere. So 1 over 2, 4 over 3 pi r cube plus volume of cylinder is area of the circle multiplied by height. So pi r square h. Now in both of these terms we have pi r square common, so we can take that out. So the volume we have we have been given is 2880 pi equals to pi r square 2 over 3. So I just divided 4 by 2, so 2 over 3 r plus h. Now I will just take pi r square on the opposite side, so this will be 2880 pi over pi r square equals to 2 over 3 r plus h. So if I'm in h subject, so h equals to 2880 over r square minus 2 over 3 r. So we have expressed h in terms of r. In the next part, it asks us to show that the external surface area of the object is given by this equation. So if we look at our object, so there is this hemisphere, so we will just consider surface area of this outer shell of the hemisphere. So we are given surface area of sphere, so we will just divide it by 2 and we will get surface area of hemisphere. And for cylinder, we will take area of this outer shell and of this circle. Okay, so we have 3 different areas that we will sum up to get total surface area of this object. So surface area of sphere is 4 pi r square plus area of the circle plus area of the cylinder, like the outer shell. So basically a cylinder, if I open up a cylinder, it looks somewhat like this. Okay, so here is this area, okay, area of circle, and for the area of the sheet, so this is h from here to here, and from here to here, this length, it's basically circumference of the circle. So area of this rectangular sheet would be 2 pi r h. Okay, over here I can divide 4 by 2, so we will have 2 pi r square, and we have pi r square over here, so we can just sum this up. So this will be 3 pi r square plus 2 pi r. Now in the previous part, we basically express each in terms of r. So we can substitute it over here. So this will be 2880 over r square minus 2 over 3r. Okay, now I will basically just multiply this whole 2 pi r with 2 AKT and 2. So we will get 3 pi r square plus 5760 pi over r minus 4 pi r square over 3. Okay, now I can just subtract 3 pi r square and 4 pi r square over 3. So if I take LCM, so I will get 9 pi r square, and 9 minus 4 is 5 pi r square. So we will end up having 5 pi r square over 3 plus 5760 pi over r. And so this is what we were asked to show. Okay, 5 over 3 pi r square and 5760 pi over r. Okay, now in the next part it says, given that r can vary, find the value of r for which a has a stationary value. So for stationary value, basically we will just need to differentiate this equation of area and equate it to 0, so to find the stationary value. So okay, so over here I'm going to just rewrite the equation of area, and I will take 5 over 3 pi common from both of these terms. So 5 over 3 pi, and we will end up having r square plus 3, 4, 5, 6, and I will take this r in denominator into numerator and put its powers to minus 1. So r minus 1. Okay. Now let's differentiate this with respect to r. So dA over dr, this is 5 over 3 pi. If we differentiate r square, so we will have 2r, and if we differentiate 3, 4, 5, 6, r minus 1, so minus 1 will become the coefficient over here, multiply with the coefficient, and this will be minus 2. So minus 3, 4, 5, 6, r minus 2. Okay, now we are going to equate dA over dr to 0. So dA over dr equals to 0. So let's find out the stationary value. So 0 equals to 5 over 3 by 2r minus 3, 4, 5, 6 r minus 2. Okay, so I will bring this coefficient on the opposite side, will multiply with 0 and will become 0. So we will just left with this bracket. So 2r minus 3, 4, 5, 6 r minus 2. I will take this on the opposite side, and we will have 3, 4, 5, 6 over r square equals to 2r. I will take r square on the opposite side, it will multiply with r and bring 2 at the bottom in the denominator. So we will be left with r equals to cube root of 3, 4, 5, 6 over 2. So I just brought this 2 in the denominator. So this is 3, 4, 5, 6 divided by 2. And I've taken cube root of r cube. So we will be left with this equation. Now if we solve this, so we will get r equals to 12 centimeters. So cube root of this number 3, 4, 5, 6 divided by 2 is 12 centimeters. Okay. In the next part, it says find the stationary value of A while leaving your answer in terms of pi. So R equals to 12 centimeters, area equals to 5 over 3 pi 12 square plus 3456 divided by 12. Okay, and so inside the bracket we will be left with 432 5 over 3 pi. So area equals to 720 pi. This is centimeter cube. Okay. In the last part, it asks to determine the nature of the stationary value that we have found over here, r equals to 12. So in order to find the stationary value, we will have to find the double derivative. So we have already found a single derivative of area, and we will differentiate this value, this equation again with respect to r. So let me just copy this down over here. So dA over dr is equals to 5 over 3 pi 2r minus 3, 4, 5, 6r minus 2. Okay, so let's differentiate this. So this will be d square A over dr square, and this will be 5 over 3 pi. We'll be left with 2. Derivative of 2r will be just 2, and derivative of 3, 4, 5, 6r minus 2. So this minus 2 will become the coefficient over here, and this will be plus. So this will be plus 2, 3, 4, 5, 6 r minus 3. Okay, now to determine the nature of the stationary value, we will just input the value of 12, but we do know that we will get a positive answer because this is 2 plus, and we have r, and r is also a positive value. So this whole will be just a positive value, which means that this stationary point will be a minimum. Okay, so that's the nature of the stationary value. I've also made graph of these equations so we can have a look at it. So in orange, I have made the graph of area, and in the blue, it's a graph of dA over dr. So as you can see that at r equals to 12, we have dA over dr equals to 0, and at the exact and at an area at when r equals to 12 is 720 pi that we found above, which is equals to 2262. The exact value is 2262 of this at r equals to 12. So okay, that's it. I hope you learned a lot. Thank you so much.